listening to A Bit Easier podcast, a space where we dive into science-backed tools to help you organize your life, take care of your health, and stay productive. In each episode, we explore ideas and strategies that make life feel a little simpler and more fulfilling. I'm Anna Kovalenko, a coach with a deep passion for behavior design. I truly believe that change is possible without forcing yourself, as long as you use the right strategies. And that's exactly what this podcast is here for, to share those tools with you in a clear, relatable way. So let's take this journey together. Every episode is one more step toward living life just a bit easier. Today we're talking about something that often stays behind the scenes of our decisions, reactions, and habits, about cognitive maps. These are internal frameworks our brain builds to help us navigate the world. They allow us to anticipate, plan, learn, understand others, and even to avoid potential danger. My guest is Mona Garverт, an assistant professor of neuroscience. She explains how these maps work, why they influence our choices, and how we can take control of them. This becomes especially important when our old maps start to get in the way rather than help and need to be updated. This episode is for you if you want to better understand yourself, learn more easily, make more informed choices, or break out of behavioral patterns that no longer serve you. We'll talk about memory, anxiety, learning, and how to reshape your understanding of the world when it's time for a change. If you haven't yet, please subscribe to A Bit Easier podcast, drop a comment once you get an insight, and we are moving to our conversation with Mona. Mona, hi. Thanks for joining me today. It's a pleasure to have you on my podcast, and thanks for accepting my invitation. And we'll be discussing today your topic, your research about cognitive maps. And as far as I understand, it's a key focus of your research now. And to start, could you unpack what is a cognitive map and how this concept changes our understanding of human behavior?
Yeah, well, thank you very much for having me on the podcast. It's really nice to speak to you. Yeah, so I'm generally really interested in understanding what makes us behave the way we behave. And so it's understood that the human brain essentially has multiple ways of guiding our decision making. One is to essentially repeat things that worked well in the past and try and avoid things that didn't work so well in the past. And as you can imagine, that can be a good strategy. For example, if you've been bitten by your neighbor's dog, it's a good idea to just avoid encountering this particular stimulus again in the future. But then, of course, our world is really quite complex and high-dimensional, and it changes all the time. So we constantly find ourselves in situations that we haven't quite experienced before. Like you and I have never had this conversation, for example. So how do we know how to behave in those new situations? And so the point that I like to make is that these new situations are typically in some way similar to other situations that we have experienced before. And so we can apply what we've learned in those other situations to the current one. And that's where cognitive maps come in, because cognitive maps essentially tell us how similar different experiences are to each other. And so if we know that something is nearby in our map, so to say, or as similar as possible, then we can essentially transfer everything that we've learned about this other situation to the current one. And so, for example, I can think of other talks I've given or interviews I've had and transfer the behaviors that worked well in those situations to this particular situation, because I know that this is a similar situation in some ways. So it essentially simplifies the learning problem that humans face in this complex world that we live in, and helps us behave in situations that are novel.
Mm-hmm. Mm-hmm. And how did this concept emerge? So I guess someone has created this name of map.
Yeah, so this is historically the first person to really think about this idea was a psychologist called Tolman. And he lived at a time where people thought that behavior was very much like stimulus response driven. So you would encounter a particular thing in the environment and that would trigger a particular response. And he realized that can't be it. There must be more to behavior. There must be ways of kind of simulating potential actions that you could take and then making a decision based on the outcome that you imagine or plan future actions. And so he said that for this kind of behavior, what we need is some knowledge about how things are related to each other. And so he termed this idea of a cognitive map. And so then it was at first studied in space. So Tolman himself actually studied this in space at first, in rodents. So he had them navigate around spatial arenas, and then he introduced a shortcut and demonstrated that these animals managed to identify that it's a good idea to take the shortcut. And this is, of course, only possible if they have some idea of the spatial layout. And so that was one of the early studies that demonstrated that animals clearly form some kind of map-like representation. And then there was a lot of research trying to identify the cellular basis of this. This is research that won the Nobel Prize a few years ago, 10 years ago now, by John O'Keefe and the Mosers, who are based in Norway, and they identified specific cells that tell us where we are in space. But so then became clear that there's indeed like a physiological instantiation of these maps. And only relatively recently, I think this original idea that Tolman had already expressed, which is that these maps might be much more fundamental and also guide our behavior outside of space, was taken up again. And so that's also where some of my research came in and demonstrated that these principles are really extend beyond space quite a bit.
Mm-hmm. And this extension, so could you unpack it? What do you mean when you say that it is beyond the space?
Yeah, so as I said, at first, in the last few decades, there were these important discoveries about these spatial cells in the brain. So, for example, the hippocampus, a structure that's located quite deep in the brain, was found to have place cells. So these are cells that are active when an animal or also a human is in one particular location in the environment. And if I then move on to the next location, then a different cell will be active, and the next location, a different cell will be active. And together, all of these cells essentially form a map of our environment. And it's useful to have this map because it allows me to compute shortcuts and to quickly identify how long it would take me to get to certain other locations in the environment and so on. And so a few years ago now, I would say maybe 10 years ago now, there was this idea that maybe this kind of coding principle could also be really useful outside of space. And perhaps other types of relational information might also be represented in a similar way, using the same codes, essentially. And so people came up with all kinds of ideas of, defining relationships between things. So one study by Alexandra Constantinescu and Tim Behrens, for example, at the time, essentially tried to simulate space. So by not having people navigate around a spatial arena, but instead they presented them with birds, and the birds changed in terms of the length of their legs and the length of their necks. And so in this way, they could define two coordinates. Right? So the length of the legs on the x coordinates and the length of the neck on the y coordinate. And then you can define essentially a space in this way. And they found that this kind of space was encoded in the brain in a very similar way as actual physical space, suggesting that these codes that we know, these neural codes that we know from space, extend to these non-spatial relationships. Yeah, and then we moved on and demonstrated that this is even true for sequences of objects that follow an underlying structure. So people were presented with a sequence of object that wasn't random. So it appeared quite random to them because it was quite a complicated underlying graph structure. But essentially this graph structure determined which object could follow which other object. And so we presented people with very long sequences of these objects, and then on the next day we put them in the MRI scanner to look at the representations of those objects. And we found that the brain had essentially extracted this underlying structure and formed a map of these relationships between the objects that participants experienced, even though they had no conscious awareness of this underlying relational structure. Suggesting again that participants or humans form these types of relational knowledge structures for things that have really not very much to do with space, for all types of relational knowledge.
It seems to me that it's an example of what usually is called intuition. So we may think that we just have an intuition about some information or some judgment, but basically it's just our unconscious representation of some experience or knowledge, isn't it?
Yeah, this could be true, that perhaps over time, we've accumulated a whole set of knowledge structures and, knowledge about how things are related to each other. And the brain probably is constantly busy trying to find shortcuts in these cognitive maps that we have formed. And that might feel like an intuition, indeed, which is, you're forming a new connection between things, but it's scaffolded, of course, by everything that you know already. So there are only particular shortcuts that are likely to be found by the brain, so to say, and that's given by everything that you've learned previously. I think that's an interesting idea.
Okay, good. And Mona, what inspired you to choose this field of study and focus on cognitive maps?
Yeah, I think it is really important because I think it underlies a lot of our behavior and our cognition. So as I said, right, because we are constantly in this kind of situation where we don't know or we can't rely on direct previous experience. So we have to somehow come up with likely outcomes of our actions because it's really important for the brain to make accurate predictions on what's likely going to come next. And so I think this really underlies a lot of our behaviors and our thinking and our cognition. And so that's why I'm really interested in understanding the fundamentals and what underlies these cognitive processes. And I also think that it's possible that when this process doesn't work so well, that this can lead to various psychopathologies. So there's some early evidence now that aberrant map formation leads or is associated with things like schizophrenia, for example. There's an idea that maps are really important for planning the future, and if there's some really aversive outcome expecting you in the future, this can be related to anxiety, for example, or you might overestimate the likelihood of reaching some really unpleasant state, for example, and so this can be associated with heightened anxiety, for example. So I think it's important to understand these mechanisms first in the healthy human brain, because it might give us some implications about what might be going wrong in psychopathology as well.
Okay, it's clear. I also wanted to dive in a little bit into the topic. One of your studies shows that we have two distinct zones in our brain for different types of cognitive maps. It will be a simplification, but still one for recently acquired knowledge and one for lifelong knowledge. So could you tell me more about this finding and its practical applications, if there are any?
Yeah, so I mentioned this one study already that we did where we showed people sequences of objects, right, that followed this underlying structure. And so we found that when we then put people in the brain scanner on the next day, we could essentially reconstruct this relational structure. And a lot of the time when I presented these results, people asked me, yeah, but you used everyday objects. People might have some existing knowledge about these relationships already, right? So they might know that a bed and a chair are more likely to go together than a bed and an apple, let's say. And so we then reanalyzed this data set to test where this type of knowledge, so we call this semantic knowledge about, relationships between things in the world, might be represented. And we found also a representation of this knowledge in the same brain structure, in this hippocampal formation that I mentioned before. It's not exactly overlapping, so they seem to be distinct representations, this more newly acquired relationships versus this existing knowledge about semantic relationships between objects. But this, again, I think reinforces the point that this brain structure encodes all types of relationships between things, old and new, recently acquired, acquired over an extended period of life, acquired through these kind of transitions between the objects versus, just your everyday experience of furniture belongs in the house and therefore could be the same category versus fruit is a different category, for example. So this cognitive map concept is really quite broad. It can be applied to all kinds of relational knowledge. And what we should really think about is maybe then not so much how old memory is, for example, but more about whether it's relational or not. Does it tell us something about how things are related to each other or not? And knowing how things are related to each other, as I outlined at the beginning, is really important and useful for all kinds of behaviors.
A lot of years ago, it was like not even 5, maybe more, I've heard this method of learning that you need to associate. For example, if you're learning a new language, you should associate a new word with some object. And it's easy when, for example, you learn an apple in different language. You can imagine an apple, but there are a lot of abstract words that you cannot associate with a visual stimulus. And you should imagine or capture some part of your room, for example, and associate these words with this part of your room. So I guess this approach was built on what is known about cognitive maps, so that our brain better remembers information when there is an association, as you say, relationship between two things.
Yeah. So this, you're probably referring to this memory palace technique. Is that right?
Maybe, yeah.
I think this is what some of those memory artists use, right? That manage to remember massive amounts of words, for example. And so what they often describe is that they essentially indeed have, for example, an imagined house, and they walk around the house, and in particular locations of the house, they locate these objects that they need to remember. And so they, indeed, as you suggest, right, they probably try to link the objects that they want to remember, or maybe the translation in a foreign language of those objects, to a particular place in the environment. So they're really exploiting this very well-known coding scheme, this cognitive map coding scheme, to try and remember novel concepts or novel ideas, or even just sequences of objects. And that seems to be working really quite well, suggesting that indeed the cognitive map helps us also remember sequences of events or relationships between things. So that's a way of exploiting this relational knowledge formation, I think.
Mm-hmm. Is there any information about how we can also, in other ways, use the understanding of cognitive maps to better acquire new skills, information, maybe for transformation of educational systems, something like that?
Yeah. So I think this is probably really not new for people that work in educational systems, right? But it's really, what this suggests, I think, is that it's important to try and embed new information with what you already know, right? So everyone has some kind of knowledge structure in their brain, which is what we describe as cognitive maps. And if you can link whatever you want to teach someone to this existing knowledge structure, then it will be much more likely to be retained, I think. So then the brain can, overnight consolidation, it tries to form new associations between things, and that's just much easier if you can integrate new knowledge with existing knowledge, essentially. So that would be my suggestion, to try and really find connections between what students already know and this new concept. And perhaps the other thing I would suggest is to really work with analogies, because there's this idea that we form essentially structures that have nothing to do necessarily with the specifics of a particular experience. So we have an idea, for example, of the sequence of events that unfolds when we visit a restaurant. That will always be the same, right? So you visit a restaurant in London, and what happens is that you first ask for a table, you sit down, you look at the menu, you order something, you consume, then you ask for the bill, you pay the bill, and you leave. And that's true in London, and it's also true in Vietnam, and it's also true in Peru, and right? So essentially the sequence of events is the same all over the world. So that means that if you visit a new place, you might be really surprised about the particular food you eat, but you will probably not be so surprised about the sequence of events, because you can apply what we call a schema of restaurant visits to this new situation. And so similarly, I think that if you want to teach people new concepts or new ideas, perhaps there is an existing schema already in the brain of a similar structure of something, for example. And if you can manage to lock this new concept to something that already exists, then it might be much easier for people to understand and grasp this new concept and also to remember it. And so this can work with analogies, I think, quite well, because then people can extract the structure that's existent in this analogous situation to this new concept, and that might just speed up learning and deepen memory. So those would be the two things. Try to make links to things you already know and use or really exploit knowledge about regularities that you've maybe learned in similar domains or even completely dissimilar domains, but that share some essential features that you can then apply this new knowledge to the structure.
I've stumbled a lot of times on the information about metaphors in the recent years, and that it's like a shortcut to our brain. So if you want to explain something, you should use a metaphor, and brain grasps it much easier if you explain in novel terms.
Exactly. I think this is true because essentially it's often the case that there's some essential structural information that's shared between the metaphor and the true situation that you want to map onto it, so to say, right? And so if you understood it in this context, then you can just transfer this knowledge to this other situation, and that really speeds up the understanding. Yeah.
And how flexible are cognitive maps? So are they easily reshaped if we meet novel situations, novel information, or it takes a lot of resources?
Yeah, that's a really interesting question, I think. And I don't think there has been a huge amount of research into this. A little bit in rodents and looking at how quickly these maps update and so on. I think it depends very much, but this is really just a hypothesis.
Okay.
But probably it depends on how certain you are that your map is correct, let's say. So you probably have some belief about how sure you are that these relationships are true. For example, it's probably going to be quite hard to convince you that chairs are not furniture, because this is a very deeply ingrained belief in your brain, and you know that chairs are related to tables much more than to airplanes, right? Because you've experienced this many times in your life, and so this has been reinforced over and over again. But then we, of course, have other types of maps, for example, maps of people that we maybe have encountered only quite recently, that are more flexible and are updated regularly. So, for example, the way I think about it is that when I encounter a new person, probably what happens is that the brain automatically tries to detect, okay, this person is maybe similar to this other person that I met previously, because again, it helps us categorize the likely behaviors that this other person is going to express. But then I might be surprised. I might realize, okay, you actually now said something that I didn't expect at all. And so then I have to refine my idea of who you are and what kind of person you might be. And if I don't know you very well, then this is probably relatively flexible, I would think, because I don't have a very precise map or precise model of you yet. So it depends very much, I think, on the kind of model, and it probably also depends on the individual. I would imagine that there are quite a lot of inter-individual differences in terms of how flexibly I can adapt my map. So there's one piece of evidence where we saw this a little bit in some of our data. So this was a study where we had people navigate around a virtual arena, and every now and then in particular locations they encountered little monster stimuli, and they were instructed to try and remember where each monster sits. And they could do this quite well. So we asked them to position the monsters, and they could, they learned the monster locations. But then we found that they actually, in the brain, we could identify two types of maps. So one map was really the spatial relationships between the monster, how far away in space is each monster from each other monster. And the other one was more a map that related to their subjective experience. So people took very different trajectories around the space. So some people walked mostly around the border, some people visited the center all the time, some people walked pretty randomly. And so this means, of course, that the order in which these stimuli were encountered differed quite a lot between different individuals. And we could see this reflected in the brain. So this, in addition to this objective, true distance between the monsters, we also found a signature of these subjective experiences that people had made. So the monsters that they encountered in closer temporal succession were more similar in the brain. The representation was more similar compared to monsters that were far away from each other. And then we made the spatial map relevant for behavior. So we asked people to make choices between the monsters, and how many points they would get depended on the spatial location of a monster. So monsters that are near each other in space gave more similar rewards, more similar amounts of points. And so here this subjective map was completely irrelevant. People should ignore that. They should use their spatial map and not the kind of order in which the monsters were encountered. And we found that by giving them this choice task where the spatial map was relevant and not the other one, the spatial map representation in the hippocampus also changed. It became kind of upregulated, so to say. And this more subjective map became downregulated. So this suggests that depending on the experiences we make as we walk around and live our life, we might realize that one of those maps is more relevant for behavior than another one, potentially. And so that means that the brain then changes how these maps are represented relative to each other. So in that sense, our brains are flexible. They can upregulate or downregulate how strongly a map is represented and how much it influences behavior. How flexible the map itself is in terms of when I then encounter, for example, that a monster has now changed its location, so I need to update the entire map. That we haven't tested yet, but as I said, I imagine that depends on various factors.
As you describe it, I'm just fascinated of how our brain works. So how difficult all these little interactions and relationships are. So micro relationships, and researchers need to unpack every one of it to understand how it works.
Yeah, exactly. So what I really took away from this particular study is how important our individual experiences are that we make with the world, right? A lot of the time in the kinds of studies that I do, we try to prescribe exactly what people experience when, right? So every individual will experience exactly the same thing so that we can then look in the brain and see how this is represented, for example. And in this study, we didn't do that. We had people navigate freely, explore freely. And that's when we became aware, of course, of the huge variability in terms of how people behave in the world and what that, of course, then also means about how the world is then later represented in the brain. So this is, of course, also true in our everyday life, right? So we all make slightly different choices depending on our preferences. And so therefore we experience the world differently, each individual. And therefore the world is also represented in our brains differently. And I think that's really important to think about.
I also had an episode with a researcher on reality and imagination. And we've talked also about the fact that our perception is hugely different, and we may be in the same situation as you've explained. So we have the same task, we have the same monsters, we have the same location, but we perceive it so much differently. So and you can never predict how another person will act or how this person thinks. And from one hand, it's interesting. From another, it causes a little bit of an anxiety because you never know what will happen. You cannot predict anything. It's not in our control to understand other human behavior.
Yeah. I mean, so we could predict some behaviors, I would say, in this particular study, right? So we found, for example, that people's choices in this task where they could then make points was also influenced by their subjective experiences. But what we couldn't predict is, of course, why each individual chose each trajectory in the first place, right? So at some point, this predictability stops, I guess. The kind of behavior that we express is very much influenced by previous experiences that we would have had again, right? So everyone already has some map in the brain. Everyone has some idea of how should I optimally solve this task based on previous experiences that I've had. And that then influences behavior. And I think it's very interesting that this leads to such huge inter-individual variability between participants. But yes, of course, it also makes it sometimes difficult to predict what other people will do and how other people will behave.
Okay. And you also mentioned that the research in cognitive maps is also looking into the topic of long-term planning. Could you please unpack this? So how the understanding of cognitive maps or this field of study helps us to better plan maybe, or just explains how we think about future goals and how we think about long-term planning?
So particularly when you make choices that lie quite far into the future and where you have no experience at all. For example, you make a choice about what to study at university or what career to take or whether to marry this person or not or whether to buy a house or not, right? You have no experience typically of similar situations in the past. You make this decision very few times in your life. And so you need some idea of what the likely outcome is of this action. So for example, if I choose to study medicine, where am I going to end up compared to if I choose to study law? And so in order to make these kinds of decisions, I essentially need a model of the world. I need some idea of, if I do this, then this happens next, and then this happens next, and then these are the potential opportunities that I might have. And so this model, model and cognitive map are sometimes actually used a bit interchangeably, right? So we have an idea of how things are related to each other. For example, if I choose this particular career, then I would go to university for this many years and I would do placements in these different fields, and then I would choose to become a doctor at this hospital there. And, things might change, but initially when I make this decision on whether to study medicine or law, I probably have some idea of, what the future states are going to be that unfold as I make this particular decision. And so this relies on having a map of how things are related to each other to some degree, right? So I need a map of what happens if I inscribe to university and where am I going to end up? What might my life potentially look like if I do this? And what are the steps down the line? And what's my goal down the line, right? So I mentally simulate the sequence of events that will unfold and form an expectation about the outcome that I'm likely to experience. And this I can then compare to the outcome that I think I will experience for my other potential action plans. And so I can rely, to make these computations, I can of course rely on, again, some experiences that I've made previously. So when I made this decision, for example, back in the day, I knew that I didn't really enjoy languages so much, so it's probably not a great idea for me to study language at university, right? Even though that I know that's somewhat different, but I probably use some knowledge about related experiences to generalize, my experiences then. So I know, okay, languages I didn't enjoy so much, so maybe not a good idea. I did enjoy biology and natural sciences quite a lot, and so I anticipated that probably studying something along those lines will be more similar to these experiences that I had in high school, and so therefore I chose this particular action plan. So again, essentially I have in my brain some idea of how things are related to each other, and I can use these ideas to plan into the future.
Yeah, I understand that it cannot be supported by science or research, but as this phrase came up to me, all the answers are inside of you. Oh, you already have all the answers. Yeah, we need more information usually to make a good decision, but sometimes I think that we underestimate how much information we already have.
Yeah. So I would say that there's a balance here. There is, it does make sense to use our previous experiences and everything we know about the world to make decisions, right? And at the same time, we do want to make sure that we update, as you alluded to earlier, we update our predictions regularly because the world might change. Our world these days changes a lot all the time. And so it's a good idea, not to rely on outdated maps, so to say, but to really kind of take into account, okay, what are the experiences that I make right now? Do I perhaps need to update my idea of how the world works? And so in this case, I would say that it is important to, of course, have a healthy balance between how much we rely on what we already know and how much we take in kind of new experiences and new sensory information. But yes, I think our brains are essentially constructed such that a lot of the time, whether we're aware of it or not, we use our previous experiences anyway to interpret, new incoming information very strongly. And so in this sense, I think the saying is very true.
Okay, thank you. And coming to the end, I also wanted to touch on the topic of mental health. You've mentioned that cognitive maps are useful, might be useful, and are maybe already useful in researching the reasons for some disorders, I would say. So could you tell me maybe what of your research is connected to mental disorders, and maybe you've already found some pathways for treatment, or maybe like there is a light in the end of the tunnel to find some answers?
Yeah, so I don't want to get hopes up too much here. I don't think we have gotten to the point yet of providing new treatments based on this work. But you can imagine, for example, that if you use these cognitive maps for planning, for example, or for guiding your behavior, if these maps are completely wrong for whatever reason, then you won't come to good decisions. So in this sense, I think this is very relevant. So what I've been studying now in my recent work a little bit is what happens to these maps when particular instances in them or particular experiences in the map are very aversive. So for example, in our case, what we do experimentally is that we pair things with shocks. And so we then want to see how this changes the representation of the map itself, and also how this might relate to psychopathology. So is it, for example, the case that we find distortions in our map if one location in it is paired with a really aversive experience? This might make sense, right? Because you might want to use your map to really avoid aversive experiences in the future. Ideally, you don't encounter aversive experiences directly because they are aversive. So you want to use your knowledge about how the world works to make sure that you don't get to this point. And so in this context, I think these maps are particularly important. And so now the question is, what happens when there is then a really aversive experiences integrated in your map? Does this lead perhaps to distortions in your representation that might help you making better predictions in the future so that you can then better avoid these aversive situations? We're testing this and also looking at how this might relate to things like anxiety scores the participants show. Like, is this perhaps more extreme in individuals that show larger anxiety scores, for example? So this is the kind of question that we're looking at the moment.
And is this information used in cognitive behavior therapy already?
Yeah, so I think CBT in some ways was ahead of basic research, one could say, because one feature there, I think, is that you do indeed try to get people to really question the beliefs that they have about the world, right? So they have a particular idea of, maybe how other people see them, for example, and then they're really encouraged to assess the evidence that this is indeed true, or that perhaps, the idea you have about how others see you or how the world works is not quite correct. And so if, again, you think about it from the perspective of cognitive maps, you could argue that this is a way of updating your map, related to the point that you made earlier, that if the map isn't adaptive, isn't helping you behave well in this world, then maybe it's good if you change it and make it more useful. And I think one could think of CBT or some aspects of CBT as doing exactly this, trying to get people to update their models of the world.
Okay, thank you. And what are the key questions you hope to answer in your future research?
Yeah, that's a good point. So I would like to understand more how these maps form in the first place and how they are updated, and also how emotions interact with them, because I think emotions are really important signals for behaviors, and which behaviors are appropriate and which ones are not. And they probably interact directly with these kinds of representations that we have of the world, with these models that we have of the world. So these are the kinds of questions that I'm really interested in now. And so we use studies where we get people to form new knowledge and then use this new knowledge to make decisions. And we're also interested in what happens when you manipulate activity, in particular brain structures that we know are important for this kind of behavior, like the hippocampus that I mentioned before, to see really, what the causal contribution of these brain regions might be, so that we can better understand how this kind of knowledge forms and guides our decisions.
Basically, what you've said is about the fact that usually we tend to repeat the experiences that are positive, and of course we don't want to repeat the experiences that are negative, and the maps that were built in pairing with negative emotions may cause some aversive experience, so we don't want to come back to those maps. But maybe this is a kind of behavior that rationally we would like to have. For example, public speaking. So we had a bad experience, but we want to be a public speaker, and that's the point where we need to change this map somehow, and maybe with the help of CBT, for example, or other methods, I don't know, but just an understanding of the fact that it's okay not to want to repeat the negative experience. So it's natural for our brain not to want to come back to those experiences, but it's possible to reprogram this pathway, so maybe to reprogram this experience if we have a positive one upon it. That's how I look at this topic. Maybe you have something to add.
Yeah, no, that's really interesting. I think this is really an issue where you often, by expressing these kinds of avoidance behaviors, you prevent your brain from updating your map, right? Or from learning. For example, if you then, after an aversive experience, after you've given a speech and it didn't go particularly well and you felt very, very nervous, if then the consequence is that you avoid similar situations in the future, then you cannot really unlearn this association between public speaking and fear, for example. Whereas if you maybe used new opportunities to try again, and then you realize, oh, actually it's not so bad. Maybe there was a particular reason why it didn't go well in this instance. But now when I do it again, actually I realize, okay, I'm doing okay. This helps you essentially to update your model again of the world. And this can be really useful in many situations. And I think this kind of avoidance behavior is often observed in various anxiety-related conditions, right? Where people then try to avoid the anxiety-inducing situation, and then they can't unlearn their fears. And this is also something that CBT explicitly tries to do using exposure therapy, right? Where patients are exposed to the thing that they fear the most. And again, thinking about what happens in the brain is probably indeed exactly this thing again, that you then update your ideas about associations between things and how they are associated to an anxiety or fear-inducing situation. And so, again, I think it's really useful to try and challenge yourself sometimes, especially when you encounter a situation that's perhaps fear-inducing. And first of all, really question, what's the evidence base here that this is something I should really be afraid of? And maybe use it as an opportunity to teach your brain that these fears are maybe internally constructed. The outcomes are not as bad as perhaps anticipated.
Yeah, it's true. Okay, thank you, Mona, very much for sharing your insights, and it's been fascinating to dive with you into the topic of science of cognitive maps.
Thank you. It's been a real pleasure. Thanks very much.
That's all for today. If you found this episode useful, share the podcast link with the people who matter to you. Also, if you'd like to support my work, the best way to say thank you is to subscribe to the podcast on the platform you listen to it. And if you have a moment, drop a comment to let me know what you enjoyed. See you in the next episodes.